All right, this one involves counting arrangements. Now, one of the things we've got to think of to begin with is if you've got, say you've got a password, and say your password is King with a 1 in there. Okay? Imagine that's your password. Okay, is that the same as this? I'll do it the old way. Is it the same as that? Why not? Okay. What we talk about is whether things are case sensitive or not. If the password is case sensitive, that means that K is different to that K and that N is different to that N. Does that make sense? But if it's not case sensitive, and a lot of passwords are not case sensitive, then those two are exactly the same. Does that make sense? Okay, that's the first thing you have to remember, the difference between case sensitive and not. If it's case sensitive, it does matter whether it's uppercase or lowercase, capital or non-capital. But if it's non-case sensitive, it doesn't matter at all. Cool? Cool. All right, let's get rid of that because that's the first bit and that's really important, but we'll worry about that in a second. Next thing is, okay. Okay, so if you had a 5-character password, so 5 characters, it's like playing hangman, and they can be a number or a letter, okay? And it's not case sensitive, okay? So not case sensitive, number or letter, 5 characters. How many different combinations can you get? And this is where counting arrangements come in. A lot, yeah, bucket loads, but let's work it out. How many letters are there?
5.
Hopefully you're going to say 26. Okay, so it's 26 letters. But we're talking about for each one. And 10 numbers. Which gives you a total of how many? Each one can have 36 different possibilities. Does that make sense? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, because there's only one digit. Okay, so we've got 36 different things in there. How many in that one? 36, because it doesn't matter what we use, we can use it again. You can have A. Okay, so how many in this one?
180 possibilities.
Okay, if you say 180 possibilities, you're going to disappoint me greatly.
Why?
Because for every 1 character there, if I put an A, how many can I have here? Right, I'm not adding them. Yeah. For every character, it doesn't matter what character I put there, for every single one, I've got 36 choices. So there's 36 here, and then for every 36, for every one, I've got 36 more. And then for every one of those, I've got 36 more. So you've got, imagine it as a tree. Your first thing would have 36 branches. And then off each one of those branches, you'd have 36 branches. And then off each one of those, you'd have 36 more. So you'd have 5 times, you'd have to do those 36 branches. The other way you can put it into your calculator machine is that. Does that make sense?
60,466,175.
What did you get?
60,000.
Just give me digits. 6.
60466 176.
Go. I'll put commas in. You're not supposed to, but generally when I don't know what the number's going to be, I just write it out and then put commas in so I can see where it was. Because otherwise people say 60 million, they meant 600 million or whatever. So it's easier if I just get the digits and then work it out. Okay. So there you go. That's how many.
When you ask me all the time in class, I know the answer and I just say, well, I'm trying to say what 1,000.
Well, that's why I normally just get the digits and then work it out. Okay, because I know you've got the right answer, but you struggle to speak English sometimes. Yeah. That's because English is too new for you. You want to speak Hebrew. Okay, so that's how many different passwords there are. So with 5 digits using letters and numbers, you can have 60,466,000, so almost 60.5 million. Now, here's where we're going to change it. And this is what we did with those number plates. We talked about all of a sudden there's a special requirement for the number plates. Okay, so I'm just going to rub this out. No, I'll leave that. No, I'll rub that out. Okay.
The oldest written language.
Okay. is Aramaic.
Mary.
Sumerian. Aren't meant to. Anyway, imagine the bank then changes its requirements. Okay, so that's how many passwords were available. Imagine the bank changes its requirements so that the first 3 characters are case sensitive, and the next two characters have to be numbers. Okay, so these first three are going to be letters that have to be case sensitive. Does that make sense? Yeah, probably should have done that. So the first 3 have to be case sensitive. What does that mean?
Limited. Oh, fuck all actually. So,
No, it means a hell of a lot. How many letters are there? Well, better question. How many lowercase letters are there?
oh, so it's
26. How many uppercase letters are there? How many letters are there in total? 52. Because you've got the lowercase version and the uppercase version, you've doubled the amount of letters. So the first 3 have that many different opportunities. Does that make sense?
Yeah.
Then what about the last 2? What have we got for these 2?
360.
It just is numbers. So how many numbers are there?
We're not doing it.
So now you work that out. So you had in the original part we just worked out letters and numbers combined, non-case sensitive. Now we've got case sensitive letters at the front, they're case sensitive, and then we've just got numbers. So what do we get?
I'm just going to read it out.
Read it out, digits.
1406 08
08
00.
00.
Oh, you can't do 52 to the power of 3 plus 10 to the power of 2.
Why not?
I got 140,709.
Okay, what if you did 52 power of 3 times? You got a times in there. Does that make sense?
Yep.
Yeah. Okay, so was that what you got? 14060800? Okay. So you've actually got rid of a lot of choices. And that's all because of those last 2. So that's how many passwords are possible with that combination. Does that make sense? Okay, so you just got to work out what is available on each character. And if I see people drawing these lines in there, I will not be disappointed.
That's good.
Okay? You need, what it does, it sets in your mind, I need 5 characters. And then you can put above it, how much do I need, how many options are there in this character? How many options in this character? Okay? It gives you a visual representation of what the hell's going on. And I just had it, I had the 36,
It's a double.
36, 36, 36 and 36. And I was able to just multiply them across and get my answer for the first part. And then I was able to go rub them out or put it above, put it below, it doesn't matter. And then you go, well, now I've got 52 options here. 52, 52, 10, 10.
Put it above or below because they're rubbing out our work now.
Yeah, don't rub it out.
Yeah.
Well, just put it above or below or do 2 types. You're going to have, if it's 2 questions, then do it on part A and then do it on part B. But that way you've got it visually. Does that make sense? Well, don't write it like I've done then. I'm just trying to show you.
No.
There we go. That's pretty. Happy?